Hi everyone, welcome to Dataverse Academy. In this video, I'll explain how you can build a end-to-end solution using Microsoft Fabric in Lakehouse. Here you can see I have e-commerce data which contains sales and return information, which means whenever you order something from a e-commerce website, that particular product has been either delivered to you or you may have exchanged it or returned it. So we this data set will contain the information of when you have ordered the product, when it was shipped, and what was the customer name, what was the product name, and if the product has been returned or not. And we will load that data, and we have the data in form of Excel file. So we will upload those Excel files into the files folder of Lakehouse, and after that we will use the Spark notebook to load the data into our bronze layer and gold layer. So in the bronze layer we will create one table in which it will contain the sales and return information, and after that in the gold layer we are going to create a dimensional model which will contains like product dimension, customer dimension, date dimension, order priority dimension, ship mode dimension, and at last we will have our fact sale table. After loading the data into a gold layer, we will create a semantic model, and at last we will connect to the semantic model using Power BI, and we will create a report. Log into your Microsoft Fabric account, then click on Synapse Data Engineering. Now, first we will create a workspace. So for that, click on Workspaces and then click on New Workspace. And we will give name to our workspace. Then click on Apply. Now we will create our lakehouse. So for that, click on New, then click on Lakehouse and provide name to your lakehouse. Then click on Create. So our lakehouse is created successfully. So here you can see two folder. One is for tables and another one is for files. So inside the file folder, you can upload files as well as folder, and you can create your own folder as well. And inside the table, we will have our delta table. As we know, in this project, we are going to use the e-commerce data. So we have sales information and return information. So in sales worksheet, we have order ID, order date, shipping date, aging, ship mode, and product information. Then what is the sale, profit, discount, what was the shipping cost, then what is the order priority, whether it's medium, high. Then we have customer information, and inside the return we have all the products which are returned by the customer. So now we will upload these files in our files folder in Lakehouse. Now let's go to the Microsoft Fabric. This is the Lakehouse which we have created earlier. So click on your Lakehouse. Inside the Lakehouse, we can see files folder. So before loading it, we will create new folder which is current, and I'll again create another folder which is archive. Click on create. Now inside the current folder, I'll upload my e-commerce data. So click on these three dot, upload files, then click on this folder. Here you can see I have these two files. Select both of them, then upload it. Then click on upload. Both of the files has been uploaded successfully. Close this. Now we will create a notebook to load the data of these files into our delta table, which will be our bronze table. So for that, click on open notebook, then click on new notebook. Now we will read some library of PySpark and pandas to read the Excel file. Right from PySpark.sql import star Then I'm reading the functions and types and pandas as PD. Using the pandas, I'll read the CSV file and then I'll create the Spark data frame. So run this. Now we will read the sales sheet data. As you know, we have two sheets in our Excel file. One is sales and another one is return. So now what we are going to do, we will read sales information in one data frame and returns information in another data frame, and we will join both of them and we will load the data into our bronze table. So let's first read our sales information. pd.read excel, and inside this we will provide the file location. So click on this current folder and copy abfs path and paste it here, and then slash sales star dot xlsx, so that we can read all the files which are under the current folder. And now we need to provide the sheet name, which is sales. Let's run it. And now we will create a Spark data frame for sales. So for that we need to write Spark dot create data frame and then pass this pandas data frame inside this. Now let's check the data inside this data frame. So we will write df1 dot head and we will pick first 10 rows and we will display it. Run it. You can see we have order date, order ID, shipping information, aging, and other customer information and sales information. Now we will read the return sheet from the file. So for that, copy this and paste it here and just change the sheet name to returns. And now we will change the data frame name as well. Run it. And let's create the Spark data frame for this and pass the returns data frame. Run it. And let's check the data inside this. So for that, head 10 rows and display it. Inside this we have order ID, customer name, return, sales amount. Now we will join both the data frames based on order ID, and from return information we will pick the return flag. Right, df1 dot join df2 df1 dot order underscore id equal to df2 dot order underscore id, comma, then how it will be left join, because we have all the data in our sales sheet, but inside the return sheet we just have only return records. So it may be a scenario like from 10,000 record we just have only 10 order IDs which are returned. So we just need the return flag for those 10 order IDs, whether these are returned or not. If and for other order IDs we'll mark that flag as no. Now write bracket, then show it. You can see we got the data, but order ID, customer name, and sales amount is repeating two times. Here you can see customer name and then sales. So we will drop order ID, customer name, and sales amount, which is coming from our DF2. So for that, write drop DF2 dot order underscore ID comma df2 customer underscore main comma df2 underscore sales underscore amount, and then show it. You can see those extra column has been removed. Now we will take this inside the df final data frame. Let's run it. Now I'll add some extra columns to my data frame, which will be order year, order month, and on the basis of that column, I'll create the partitions in my bronze table, and two more column which will be created timestamp and modified timestamp. So on the basis of that, we can decide when that record has been inserted into our bronze and when that record has been modified. So let's do it. The final dot with columns. You can see I have added order year and I'm taking the year of order date, and order month I'm taking the month of order date, and created timestamp I'm taking the current timestamp, and for modified timestamp I'm taking the current timestamp, and I'll take it inside my df underscore modified data frame. And over the modified data frame, I'll create a view so that I can use that view to load the data into my bronze table. For that, write df underscore mode dot create or replace temporary view, and view name is view sales. Run it. And now we will create our bronze table. So for that, I have already created the create script. Let me paste it. Here you can see first I've written percent SQL, then I'm creating the table and the name is bronze underscore sales, then all the columns, and at the end I'm creating the partition based on order year and order month. Let's run it. Our table is created successfully. Now we will write the merge query to insert the data into a bronze table so that we can capture the updated as well as the new record in the upcoming runs. So for that, write percent SQL merge into our table name, which is this one, using view name, and we will give alias to both of them, and condition based on order year, order month, and order ID. After that, when matched, then we will update the records. Inside the update, you can see I'm updating all the column except order year, order month, and order ID, which are my key columns. So it means if I found a record based on these columns, I'll update other columns. Let's verify it. So for that, write percent SQL, then select star from project Lakehouse dot bronze sales, limited to 10 records. You can see we got the data. Now let's delete this. After loading the data into our bronze table, now we will create a dimensional model where we will create our fact table and dimensional table based on the columns which we have in our bronze table. Here you can see our dimensional model. So we have segregated the columns of bronze table into fact and dimensions. All the major columns like sales, quantity, discount, profit, shipping costs are in fact table, and in dimension table we have contextual and descriptive information like order priority, product information, shipping mode, customer information, then order return information, then we have calendar table. And in the fact table, we also have the keys of our dimension tables. Now let's go back to the Microsoft Fabric. There we will create the notebook for each of the table and then we will write the script to load the data into the dimension table as well as our fact table. Now we will create a notebook to load the data into our order return table. So for that, click on new, then select notebook. Now we need to attach our lakehouse. Select existing lakehouse, then click on add, and this is the lakehouse, and then click on add. Once a lakehouse is attached, you can see our bronze table. And now we will start writing the code for our order return table. So first we will import some libraries. These are the libraries which I have imported. I'm just importing the functions and types. So this type is basically for while we are creating the table, we define the column types like string, integer, and this is for functions. Like if I'm using any date function, like earlier I have used current timestamp. Let's run it. Now we will create our order return table. So for that, I have already designed the script. Let me paste it. Here you can see I'm creating my order return table if it not exists, and these are the columns which we have in our order return table, which is order ID, return, order year, order month, created timestamp, modified timestamp. And I'm partitioning the table based on order year and month. So let's run it. Now we will implement the incremental load to pull the data from our bronze table. Why? Suppose for the first run you got 1,000 records, and out of those 1,000 records you just have 10 orders which are returned. So the first run we will load those 10 records in our return table, and in the next run you got again 5,000 records, and in those 5,000 records I have 50 orders which are returned. Now my total orders which are returned is 150, but I already have inserted 100 return orders. Now I need to pick those 50 records. So for that I need to design the incremental load. So for that we will pick the maximum modified timestamp of our gold order return table. Write percent SQL, then select max of modified timestamp from gold order return table. Let's run it. So for the first time, we will get null value. To handle the null value, we will write college function and default value we will provide 1st of January 1900. Let's test it. And this is returning 1st of January 1900, and we need to take it inside a variable. So for that we will create max date variable and remove this percent SQL, and we will write our SQL query inside spark dot SQL, and this is returning one record, so we will pick the first record. So for that write first record, then run it. Let's check what we are getting in our max date variable. You can see 1st of January 1900. Now we will pick required column from our bronze sale tables, which are order ID, return, order year, order month, created timestamp, modified timestamp, and we will insert in our gold order return table. Now write percent SQL and we will pick these order ID, return, order year, order month, created timestamp, modified timestamp from our bronze table. Let's try to test it. We are getting the output and now we need to apply the incremental logic. So for that, where modified timestamp is greater than, here we will provide the variable and we need to put the SQL query inside the bracket and we will write spark.sql, then after that format, and inside format we will provide our variable and close it and remove this, and we will pick it inside our data frame. And one more thing, we need to put it under single quote. Now let's run it, and the data has been saved into our data frame. Now we will simply insert the data into our order return table. Why? Suppose you have ordered something from an e-commerce website and you have returned it. So it will not be a scenario where that return product will move to that previous state. It may be a scenario when you do some exchange. But right now we have orders which are returned. So now we will insert the data into our order return table. Before inserting the data to our order return table, we will create a view for this data frame. For that, write df create or replace temporary view and view name, and then run it. Now let's verify the data into this view. Run it. You can see we got the data. So here we are getting return as null. Why? Because we have taken all the data from our bronze table, but we need only the orders which are returned. So we need to change our query to return equal to yes, and then run this again and run this again, and let's check our view. You can see now we are getting only those orders which are returned. Now we will insert the data from this view to our order return table. Remove this and write insert into Lakehouse name dot return table name, select star from view, and then run it. Data has been inserted into our gold order return table. Let's check the data. Right, percent SQL, then select star from, limit it to 10 record. You can see we have the data into our table. Now remove this, and after this we will load the data into our order priority table. Before that, let's change the name of our notebook. For that, click at the top and write gold order return, and now click on your workspace, then click on your lake house. Here you can see our bronze table and gold order return table. Now we will create a notebook to insert the data into our order priority table. For that, click on open notebook, then new notebook. And now we will import some libraries. Till now, we have used Spark SQL to insert the data into our bronze sales table and order return table. But for order priority, we will use PySpark to create a delta table as well as to implement the incremental logic and to insert the data into our order priority table. So for that, we need to import one more library, which is from delta.tables import star and then run it. Now we will create our order priority table. For that, write delta table dot create if node exists, and inside this we need to provide the spark variable. After that, go to the other line and then dot table name and then dot table name. Here we need to provide our table name, which is gold underscore order priority. And now we will add our columns. For that, write add column and provide your column name. First column name is order priority ID, which is long type. And then here we need to provide the order priority. Created timestamp, which is timestamp type. And then dot add column and modified timestamp, which is also timestamp type. And then write execute. Without execute, your table will not be created. Now let's run this. Our table is created successfully. Now we need to implement the incremental logic. For that, we need to pick the goal priority table into a data frame. So write spark dot read dot table, then Lakehouse name dot your goal priority table, and take it inside a data frame. Run this. And now we will select the maximum modified timestamp from our goal priority table. For that, write df.select expression, and inside this max of modified timestamp, and it will be null for the first run. So we need to write college function and we need to provide the default value, which is 1900 0101. And then we need to pick the first value and we need to store it inside a variable, which is max underscore date. Then run this. Let's verify what we have inside our max date variable. Run this. You can see 1st of January 1900. Now we need to pick the required columns from our bronze sale table. So for that we need to take it inside a variable. So copy this and paste it here and we will rename it as df bronze and our table is bronze underscore sales. Run this and from this data frame we will pick the order priority column. Select order underscore priority Then we need to drop the duplicates. And let's show this. You can see we have these four priorities, and now implement the incremental logic which we need to apply before drop duplicate, right? Where call modified timestamp of bronze sale is greater than max date, and then dot drop duplicates and take it inside a df underscore bronze underscore mod data frame. Run this and let's verify what we have inside this data frame. We have our four order priorities. Now we will add the incremental column, and for that we need to use monotonically increasing id function. Why we need the incremental column? Because here we have order priority which is not inside our bronze sale, and this is the key for our order priority table. And before that we need to pick the maximum value of order priority id. Why? Suppose for the first run you got 10 records, then your id will move from 1 to 3 to till 10. And again, if you insert the data using monotonically increasing id, it will again start from 1 and then it will go to like 2, 3, 4, 5, 6. That's why we need to pick the maximum order priority ID so that we can add monotonically increasing ID function with this one, and it will be start from 11, 12, 13 like this. So remove this. So let me show you what I'm trying to say. Remove this and we will pick the maximum ID of our order priority table. So for that we have taken our table order priority into df data frame. So write df dot select expression max of, and which is under bracket max of order priority underscore id, close this bracket, and for the first time it will be null because we will not have any record in our table, and the default value will be 0, and we need to pick this value inside this variable. For that, write first value and then run this. We got it inside max id. So to verify it, let's run this, which is 0. Now we will set our incremental column id using monotonically increasing id function. So we will add inside this data frame using with column and order priority underscore id max of id plus monotonically increasing id plus 1, because we need to start it from 1, and we will take it inside our df final data frame. Before running this we need to change it to function, otherwise you will get an error. Now run this and let's check the value inside our df final data frame. So we have our order priority and order priority ID. Now we will write the merge using PySpark to insert the data into our order priority table. So before writing the merge code, we need to take our order priority table as a delta table into a variable. So for that, write delta table dot for path, and it takes two variables. One is spark and another one is table. which is gold underscore order priority, and we will take it inside a variable. So for that, write tf gold underscore delta equals to, and we will also change the name of our df final data frame to df branch table equals to df final. Now we will write our merge code. So for that, copy this and paste it here, then give alias name to it, which is gold, and then dot merge, and inside merge write df branch table dot, give alias to this as well. We will alias it as branch, comma, and go to next line. And here we need to provide the condition on which we want to check whether that record has been exist or not, which is order priority, and it should be inside double quotes. And after this we need to write dot when matched update, and here write set. So we will update only the modified timestamp because we have only one order priority column. If it already exists, then we will update the modified timestamp only. So here we are updating modified timestamp with the current timestamp, and after this write when not matched insert values, and this is also dictionary, and here we will insert the data into our all columns: order priority id, created timestamp and modified timestamp. For created timestamp and modified timestamp, we will use current timestamp function. And after this, we need to write execute. Now run this. Data has been inserted into our table. So let's verify the data. For that, write percent SQL select star from our gold underscore order priority table. So we have these four order priorities. Now delete this and change the name of our notebook. Click here and then write bold underscore order priority. Close this notebook and go to your Lakehouse. Click on open notebook, then new notebook. Now we will import some libraries, and after that we will create a shipping mode table. Run this. Now we will create our ship mode table. For that, write percent SQL and create table. If not exists, then lakehouse name dot gold underscore ship mode table, and then write columns. So we need ship mode ID, ship mode, created timestamp, and modified timestamp in our ship mode table. So this column will come from our brown shell table, and these two columns we will create based on timestamp. And this is our incremental column. So for that, we will use the monotonically increasing ID function. For incremental load, write spark dot SQL, then quotes, and inside this, write select max of modified timestamp, and this will be null for the first time. So we need to write Coley's function, and our default value will be 1st of January 1900 from our ship mode table. And then we will pick it inside a variable, which is underscore date. Run this and let's verify what value have in our max date variable, which is 1st of January 1900. Now we will pick the sales mode column from our bronze sales based on incremental logic. So for that, write spark dot SQL and select distinct ship underscore mode from project underscore lakehouse dot bronze sale table, and write where modified timestamp is greater than, and here we will provide the modified timestamp value, which is max date, and then write dot format max underscore date, and then we will pick it inside a uh, okay, I think we need to pick it inside a data frame. So for that, we don't need to use the first function. We need when we only need a single value, but this will return a data frame. So for that, write df underscore branch equals to, and then run this. And now let's verify the value here. Dot show, run this. You can see we have four values, and we will insert these value inside our gold ship mode table. So for that, first we need to add columns in this data frame, which is our incremental column, then created timestamp as modified timestamp. First, we will insert the incremental column. So for that, we need to pick the maximum value of our ship mode ID from gold ship mode table. For that, remove this and then write spark dot SQL, then select max of ship mode ID from our gold ship mode table. Copy this and paste it here. And for the first time, it will be null. So we need to write college function and default value will be 0. And we need to pick it inside a variable because it will return single value. For that, we will use first function, and let's pick it inside max underscore id. Run this, and we will use this max underscore id with our monotonically increasing id function. So for that, write df underscore branch dot with columns, then here ship mode underscore id and monotonically increasing id function plus max underscore date, not date, max underscore id and plus 1. and we will take this value inside our tf underscore final data frame, and for final data frame we will create a view, create or replace temporary view, and we will use this view to load the data into our goal ship mode table. Run this, and now let's check the value inside our view. For that, write percent SQL select star from ship mode. You can see we have four values and their IDs. Now we will use the merge function to insert the data into our gold ship mode table. Right, merge into, then lakehouse name dot gold ship mode, and give alias name to it using view ship mode, and we will give alias to this as well. Condition will be on ship mode column. If the ship mode value is changed, then we will insert. If it is same, then we will update the modified timestamp only. Now write ship underscore mode equal to ship underscore mode, and give alias to both of them, gs dot and vs dot. When matched, then we will update our modified timestamp with underscore timestamp. And before that we need to provide update set, and when not matched, then we need to insert the data into our columns. Right, insert, and here we need to provide column names, then values. Columns are, then we need to provide values which will come from our view ship mode, and here we have ship mode id and ship mode, and for created timestamp and modified timestamp we will use the current timestamp function. Copy this and paste it here, and let's provide the comma and then run this. You can see data has been inserted. Now let's verify the data. For that, write percent SQL select star from gold underscore ship mode. Run this. You can see all the four records: first class, same day, second class, standard class. Now delete this and close our notebook and go to your Lakehouse. Click on open notebook, then new notebook. First we will import our libraries. For that, write PySpark.sql import star from PySpark.sql.functions import star from PySpark.sql.types import all, and run this. Now we will create delta table for our customer. For that, write percent SQL, then create table. If not exist, then table name. Before that, we need to provide our lakehouse name, which is project underscore lakehouse. And let me correct this. Dot gold underscore customer, and then provide your columns. For customer table, we have customer ID, customer name, segment, city, state, country, region, created timestamp and modified timestamp column. And after that, write using delta, and then run this. Our table is created successfully. For these columns, we will pick the value from our bronze sales tables, and for created timestamp and modified timestamp, we will provide current timestamp value. Now, to implement the incremental logic, we need to pick the maximum of modified timestamp. So for that, write arc.sql, then we are selecting the maximum of modified timestamp from our gold customer table, and for the first run it will be null. So we are using college function, and default value is 1st of January 1900, and we are taking it inside a variable. Run this. Let's see what we have inside our max date variable. Run this. You can see 1st of January 1900. Why? Because we don't have any data in our gold customer table right now. Now we will implement the incremental logic. So for that, write spark.read.table, and here we are providing the bronze shell table name, and we are taking it inside a df underscore bronze data frame. And after this, from this data frame, we are selecting only the required columns which we need to insert in our gold customer table. Then we are implementing the incremental logic. So here you can see I'm applying where condition where modified timestamp is greater than the max date. And then I'm deleting the duplicate records if we have any duplicate records based on these column combination. Let's run this. Now we will create a view for this df final data frame, and using that view we will insert the data into our gold customer table. So for that, write df final dot create or replace temporary view, then view name, and run this. Now let's verify the data inside our view. For that, write percent equal select star from our view customer. Run this. So we have customer ID, customer name, segment, city, and state. And then country and region. Now we will write the merge statement to insert the data into our goal customer table. Before that, delete this and write percent equal, then your merge statement. Here you can see I have written merge into our gold customer, and then I'm giving the alias name to it and using view customer and giving the alias to this, and I'm checking based on customer ID whether that record has been exist or not. And if that record exists, then I'm updating the customer name, segment, city, state, country, region, and modify timestamp. And if the customer ID doesn't exist in our gold customer table, it means it's a new record. Then I'm inserting the data into our gold customer table. So here we need to provide the alias name gc dot and then vc dot. And now run this. Data has been inserted successfully in our gold customer table. Now let's verify the data. For that, write select star from gold underscore customer, and we will limit it to only 10 records. So here we have customer ID, customer name, segment, created timestamp, and modified timestamp. And now let's delete this and change the name of your notebook, which will be gold underscore customer. And now close the notebook and go to your Lakehouse. Then click on open notebook and new notebook. We will use this notebook to create the gold product table, and then we will insert the data into that particular table. First, we will import some libraries. Now let's create our gold product table. For that, write percent SQL, then create table. If not exist, then Lakehouse name dot gold underscore product. Now here we need to provide the required column names, which are product ID, product category, product, created timestamp and modified timestamp. These two columns value we will pick from our bronze sales table, and this is our incremental column. So for that we will write the monotonically increasing ID function, and these created timestamp and modified timestamp we will pass the current timestamp value. After this, write using delta, our table is created successfully. Now we will pick the maximum modified timestamp from our goal product table to implement the incremental logic. So for that, you need to write spark.sql, and inside this, here you can see I'm selecting the maximum modified timestamp, and for the first run it will be null. So we need to provide the default value from our goal product table. Then I'm selecting it inside a max date variable. Now run this. Now we need to select product category and product column from our bronze sale table, and we will apply the incremental logic using max date variable. So for that, we need to write spark.sql, then select unique product category and product from your bronze sale table, and here we are applying the incremental logic, and we are selecting the incremental data based on modified timestamp, and here we are passing our max date. Now let's run this. Now we need to write monotonically increasing ID function for our product ID, which is an incremental column because it's not coming from the bronze cell table. Here you can see I have product category and product, but I don't have the product ID. So this I need to make it as a incremental column. So for that we need to pick the maximum of our product ID from our gold product table, and then we will add monotonically increasing ID function to the maximum of product ID, and we will insert the data into our goal product table. So for that, write spark.sql, select maximum of product ID, and for the first run it will be null, so we are providing the default value 0, and we are taking it from goal product table, and we are putting it inside a max id variable. So run this. Now we will add this max id into a monotonically increasing id function, and we will add that particular column into a df bronze data frame. So for that, write, so we are adding product id column within our data frame, and we are selecting the maximum id plus monotonically increasing id function plus 1. Why we are doing this? So suppose for the first run you have inserted 10 products, so your id will go from 1 to 3 to till 10, and again you got some new product and product category. If you don't take the maximum of product id and don't add it inside the monotonically increasing id function, again it will start from 1, 2, 3 and so on. So that's why we need to pick the maximum of product id, and then we will add the monotonically increasing id function here. So suppose you pick the maximum 10, then it will be start from 11, 12, and then 13, and then 14 and so on. So that's the reason we are picking the maximum of product ID. Run this, and after this we will create a view for our df final data frame. So we have given the name to our view as view product. Run this, and let's verify the data inside our view. So for that, write percent SQL select star from view product. Limit it to 10 records. So here you can see we have different categories and different product and their product IDs. Now we will write the merge function to insert the data into our product table from our view. So for that, delete this and write percent SQL, then your merge statement. So inside the merge statement, you can see I have written merge into our gold product table and give alias to that your table and using view and giving alias to our view. And then I'm checking based on product and product category whether that record has been exist or not. If it exists, then we are modifying the timestamp of our record. Otherwise, if it doesn't exist, then we are inserting the product id, product category, created timestamp and modified timestamp. Let's run this. Our job is completed successfully. Let's verify the data. So for that, write percent SQL select star from gold underscore product table. Now run this. You can see we have product ID, then product category, product created timestamp and modified timestamp. Delete this and rename your notebook, which is gold underscore product. Now close your notebook and go to your Lakehouse. Then click on open notebook and new notebook. First, we will import some libraries. Now we will create our goal date table. For that, write percent equal and create table. If not exist, then our lakehouse name dot bold underscore date table. And inside our date table, we will have our business date, year, month, quarter, and week. Now, write using delta, and we will make it partition based on business year. Let's create it. Our table is created successfully. Now we will insert the data into our goal table. So one way is we can use the order date or either shipping date of our bronze sales table. Then we can insert the data into our goal table. And the other way is you can specify the date range, the start range and the end range, and then you can insert the data. So I'm going to use the second one. So let's create two variable start date and I'll write data from 1st of January 2015 to end date till 31st of December 2030. Now we will take the difference between both of them and then we will store it inside a variable. So for that, write spark dot sql select date underscore diff, and inside this we will path both our dates, so they will go inside a single bracket, and after that write format and provide your variable name start date comma end date, and then we will pick it the first value and we will store it under date difference. Let's run this and verify the date diff. You can see it's giving value in negative, so I think we need to change it to end date will come first, start date after that. Run this. Okay. Now we will generate a range of numbers from 0 to 5843. So for that, write spark dot range, start value is 0 and the end value is date diff. It will give you a series of numbers and we will store it inside one variable. So run this and let's see what we have inside our ID data. You can see we have series of numbers and the column is ID, and we will use this column to generate the dates. So what we will do now, we will keep on adding numbers to this date so that we can get the range of dates. Like if I add like if I add one day, then I'll get 2nd of January. If I add 2 days, then 3rd of January. So we will use this ID data. For that, write id underscore data dot select expression, and inside this date underscore add function bracket, and inside this we will provide our date, and then we will add the id value which is coming from this series, and then write dot format because we need to provide our start date here. Write start date and then show it. You can see we are getting the range of dates. Now we will give the name to our column. So for that, write as business date, and let's store it inside a data frame. Date underscore data. And using business date, we will generate year, month, quarter, and week. For that, we will create a view for this data frame. Create or replace temporary view. View name is view date. Run this. Now write percent SQL, then select start from view date and then run it. You can see we have the range of dates. Now write year of business date and give name it as business year. Let me check the column name. Yeah, we have business year. And the next column is business month. Copy this and paste it here. Then week, then quarter, and then use month for this and quarter and weekday. Rename columns to business month, business quarter, and business week. Run this. You can see we got our output. Now we will insert the data into our goal date table. For that, write insert into Lakehouse name dot gold date table. And before this, whatever data we have inside our goal date table, we will delete it because this query will keep on running. So first we will delete whatever data from our golded table and then we will insert it. Run this. Let's check the data into our golded table. Select star from gold underscore date. You can see we have the data, and let me move both the queries to different tabs so that we can get idea how many rows has been deleted, how many has been inserted. So let me run delete one. You can see 5843 rows has been deleted from our gold date table. Now let's insert all the data. Run this. Our job is completed successfully. Let's verify the count. Select count star from gold date. Run this. Here you can see 5843. So remove this and rename our notebook gold date and close this notebook and go to your lakehouse. Now we will create a notebook for creating our Excel table, and inside the table we will insert the data using Spark SQL and PySpark. For creating the notebook for our Excel table, let me show you the bronze shell data. So here you can see we have sales information and quantity, discount, profit and shipping cost. These are the main measures which we are going to load into our Excel table. You notice that 62 we have a sale in this column and quantities are 5 and here 1. So for one quantity we also have the 62 as a sale, and for 5 quantity also 62 as a sale. So it means our sales column contains the price of one quantity. So for one sneakers we have 62 price, and our sale for 5 quantity will be 62 into 5. So we need to derive our sales column based on the multiplication of sales and quantity, and we will rename our sales column as price column. Now click on open notebook and click on new notebook. Now we will import some libraries, run this, and now we will create our Excel table. So for that, write %% SQL create table. If not exists, then your lakehouse name dot our gold fact cell table, and here we need to provide our column. Inside our fact cell table, we will have order ID, price, quantity, sales, discount, profit, shipping cost, order date, shipping date, product ID, order priority ID, ship mode ID, customer ID, order year, order month, created timestamp, and modified timestamp. So here you can see these are all major columns, and this is the order ID which is coming from our bronze sale table, and we have shipping date and order date which is also coming from our bronze sale table, and we will connect both of them with our dim product table in our semantic model, and product ID which will come from our gold product table, and order priority ID will also come out from our order priority table. Then we have ship mode ID which will come from our gold ship mode table, and then we have customer ID. So this customer ID is coming from our bronze seal table, and we will join it with the gold customer table. Then these two columns we will derive based on order date, and these are the created timestamp and modified timestamp. So for these two columns we will use current timestamp. Now write using delta, and we will create partition based on order underscore year and order underscore month column. Now run this. Our table is created successfully. Now we will implement the incremental logic to pull the data from our bronze sales and other related tables. So for that, we will pick the maximum modified timestamp of our fact sale table. For that, you need to write spark.sql, then select college max of modified timestamp because for the first run it will be null and we are using the college function and that will return 1st of January 1900 from our gold fact sale table and we are taking the maximum value which is coming from our gold fact sale table into a max date variable. Now run this and let's verify what we have inside our variable. You can see it's giving 1st of January 1900. Why? Because now we don't have any data in our Excel table. Now we will pick the required columns from our bronze cell table and from dimension tables by joining based on key columns. So for that, write spark.sql and inside the codes we need to select order id and here you can see we are taking sales as price because in our bronze table in the sales column a price for a quantity is given and then we have quantity column which is also coming from bronze sale table then we are multiplying sales and quantity to get the actual sale and then we have discount which is also coming from sales profit then shipping and order date and shipping date we can also get it from our dim date table. These columns are already provided in bronze sale table so we will just join them with our dim date table in our semantic model and then we have product id which we will get from our gold product and order priority id from gold order priority table ship mode from gold ship mode table and then customer id is already provided inside the bronze sale so we are picking it from bronze sale table and then we will join it with our gold customer table in the semantic model. Then we have order year and order month, which we are getting from our order date. So here we are selecting the data from our bronze sale and then we are joining with our gold product, ship mode and order priority. Okay, say here I have done something wrong. So you can see we have product ID which is not in our bronze sale table. So we need to join it based on product and product category. And same thing also we need to do for ship mode because we don't have the ship mode ID in our bronze sale table. So we need to join it based on ship mode and we will get the ship mode ID from our gold ship mode table because we are inserting ID columns in our Excel table. Here you can see product ID, ship mode ID, and these are not exist in our bronze sale table. So on the basis of product and product category, we will get product ID, and on the basis of ship mode, we will get ship mode ID. And same for order priority also. We need to join it based on order underscore priority and we will get order priority from our gold order priority table. Now let's run this. Now we need to create a view for our data frame. So copy the name of the data frame and paste it here and write create or replace temporary view and view name will be view fact sale and run this. And now we will write the merge query to insert and update the data into our fact sale table. So for that, write %% then merge into our fact sale table name, which is this one. Copy this and paste it here and give alias to it. And using view and give alias to this as well on we need to write the condition here. So we will check based on order year, order month, and order ID whether that particular record has been exist or not. Why we are taking order year and order month, not just the order ID? Because order date is never going to be changed. So suppose when you order something, a date will be assigned, like when, at what day you have ordered, and that date is never going to change for a particular order. So it means, if suppose there is any change for particular order ID, we need to check in that partition only and sub partition only. So we will check for that particular year and that particular month, and in that sub partition we will check for that particular order ID. And if that order ID exists, it means we have an update for that particular record, and we will update only in that partition, not on the whole table. And if that order ID doesn't exist in that partition, then we will create a partition based on date, and then we will insert that particular record. So now write your condition based on those columns. After this, when matched, then update set, and here we need to provide the columns on which we need to update our record. So these are the columns on which we will update our record. Then when not matched, then insert. Here we need to provide column names and then values. Columns and then values. So here you can see, except order year, order month, and order ID, we are updating all the records. And also we are not updating the created timestamp, because on the basis of that we can decide when that record has been inserted. And here we are just inserting the data based on all columns and providing the correct timestamp for created timestamp and modified timestamp. Now run this. Our job is completed successfully. Let's verify the data. So for that, write %% and select star from our gold fact sale table and limit the record to 10. So you can see we have the output, and here order ID, price, quantity, sales, discount, then profit, then shipping cost, order date, shipping date, product ID. Okay, so on the basis of product and product category, we got product ID in our table, and then order priority, which is based on order priority table, and then ship mode ID and customer ID, and order year, order month, and created timestamp. So based on order ID, we will join fact sale and order return table, and based on shipping date and order date, we will join both of them with our goal date table. And then we have product ID, order priority ID, and ship mode ID. So for product ID we will join product table, and order priority we will join order priority table, and ship mode ID we will join ship mode table, and for customer ID we will join customer table. So this is how we will join our tables in a semantic model. Now delete this and rename your notebook gold underscore fact sale, and close the notebook and go to your Lakehouse. Now, after loading the data from our current folder to our bronze sales and then to our gold dimension tables and fact table, we need to archive these files to the archive folder. So for that, what we will do, we will create a notebook, and then we will mount to our files folder, and we will move the files from current folder to archive folder. So for that, click on open notebook, then click on new notebook. Microsoft Fabric has provided an API to mount to our Lakehouse through notebook. So for that, write from notebook utils import ms utils and then run this. And then write ms spark utils dot fs dot help and then run this. This will give you the list of commands which you can use inside a notebook when you are mounted to the lakehouse. So for our purpose, now we will mount to our files folder. So for that, write ms spark.utils.fs.mount, and inside this we need to provide the path of our files folder. Click on these three dots, then copy abfs path and paste it here, and then comma, because it takes two arguments, and here we need to provide the mount variable, so we will provide it as files and then run this. Now our lakehouse is mounted to this point, and let's check the path for this point. For that, write ms spark utils dot fs dot get mount. Here we need to provide the mount point and run this. So this is the mount path for our mount point. Now we need to move our files from current directory to archive directory. So before moving, we will check whether we have files inside the current folder or not. If yes, then we will move the files, otherwise we will not do anything. So for that, write check files equal to mssparkutils.fs.ls, and here f file dot semicolon double slash, and copy this path and paste it here inside the curly bracket. And after that we need to write current folder, because we need to see what files we have inside our current folder. Now run this and let's check what we have inside our check files variable. So you can see we have path for our each file and file name and what is the size. So using this variable, we will move one file by file into our archive folder. So for that, write for file in check files, and then if our file path exists, then we will move our files from current directory to archive directory. So for this, copy this command and paste it here, and copy file.path and paste it here, and we need to use mv for moving file from one location to another, and we need to move to archive. This variable file.path will contain the location of each file, and we need to move that file to archive folder. So now let's run this and let's verify our current folder. Refresh it. You can see file has been deleted. Now let's check our archive folder. We can see the files in our archive folder. So suppose if we haven't received any files in our current folder, then in that case also our job should run and it should succeed and it shouldn't do anything. So let's try to run our job. Mount it to a variable, and let's get the mount path, and after that we'll check whether we have files or not, and then we will move the files if we have the files. So we don't have any files, so it won't do anything. So this is how you can mount to a files folder of a lakehouse using notebook, and you can move files from one location to another. Rename your notebook archive underscore files and close your notebook and go to your lakehouse. Now we will create a notebook, and inside that notebook we will call all of our other notebooks. So for that, click on open notebook and new notebook. To call all other notebook, we need to import MS Spark Utils API. So for that, write from notebook utils import MS Spark Utils. Then run. After that, write ms spark utils dot notebook dot run, and here we need to specify our notebook name. So you can see archive files, bronze sales, gold customer, and all of them. So now first we need to call our bronze sale, and then rest of the other. Before that, we need to check whether our file is in the current folder or not. So for that, we need to mount our files folder, and using that we will check whether file exists in the current folder or not. So remove this. Now we will mount to our files folder. So for that, ms spark utils .fs .mount, and then provide the path of our files folder. Click on these three dots and copy abfs path and paste it here, and then comma, and here we need to provide the mounting point, right, files, and then run this. Now let's check the mount path. Copy this and write ms spark utils .fs .get mount path, and inside this provide the mount variable and run this. So this is the mount path, and now we will create a check file variable. Using that variable, we will find whether the files exist in our current folder or not. If the file exists, then we will run our notebooks. So for that, write check files equal to spark utils.fs.ls, and then f and file semicolon, then double slash, and copy this path and paste it here, and then you need to specify current folder here, because inside the current folder we will check whether the file exists or not. Let's run this. Let's check what we have inside our check files variable. Run this. You can see it's blank. Why? Because we don't have any files inside our current folder. Now, if check files is not null, then we will run our notebooks. So for that, write ms spark utils dot notebook dot run, and here first is our bronze sale. After that, other notebooks. Let's run this. It will not run because we don't have any files in our current folder. If we got any files, and when we run our notebook, it will run all of our notebook. Now close this notebook and go to your lakehouse. Now we will create a data pipeline to run our run load notebook. Inside our run notebook, we are running our all other notebooks. So for that, click on your workspace, then click on new, then data pipeline. Give name to your data pipeline, then click on create. Now select the notebook activity and give name to your notebook, and then click on settings and select run load notebook. Then save it. and click on run to test it. Right now we don't have any file in our current folder, so hardly it will take few seconds to complete it. You can see our pipeline is completed successfully. Now click on your Lakehouse, and now we will load a file into a current folder. So for that, click on the three dot, then click on upload files, then click on this folder and upload the file. Click on upload. Our file has been uploaded successfully in the current folder. Close this and now go to your data pipeline and run this. Our pipeline is in progress. It's gonna take few minutes to complete it. Pipeline is completed successfully. Now click on your Lakehouse, then click on these three dot for bound sale and then view files. And inside the order year 2023, click and you can see the April data has been uploaded successfully. And now let's verify in fact sale as well. Click on fact sale and click on these three dot, view files, and click on this folder. You can see the data has been uploaded successfully for April folder. Now close your pipeline. Now we will build the semantic model. For that, click on new semantic model and give name to your semantic model. Then select all the tables except the bronze one. Unselect the bronze fields and then click on confirm. Now we will create the relationship between the tables. Connect gold date with gold Excel table based on business date and order date and shipping date. So first we will join based on order date. Click on business date, then map it with order date. In the relationship we need to change from one to many because we have a single record in our dimension table and multiple records in our fact cell table. Then click on OK. In the same way, we need to map business date with a shipping date. Map it with shipping date and change the cardinality to one to many and make this relationship as inactive because we can't create two active relationship between two same tables. Then click on OK. And in the same way, let's create relationship between the fact sale and other dimension tables. So we will connect customer table based on customer ID, map it with customer ID and change the cardinality to one to many. Then click on OK. And let's do it for other tables as well. For the order written and fact sale table, it will be a one-to-one relationship because order ID is unique. You can see relationship has been created between dimension table and fact table. One thing I want to show you, inside the semantic model, you can change the data type of a column and you can even format it. So for created timestamp and modified timestamp, if you want to change the date format to date, the normal one, click here. In the same way, you can change for other as well. And if you want to change the data type, click on product ID. Then you can change the data type to decimal, percentage or anything. Our model is created successfully. Now click on your workspace and here you can see our e-commerce sales model. Click on it and now if you want to create the auto generated report, for that you can click on explore this data, then auto create a report. This is the auto generated This is the auto-generated report for our semantic model. If you want to save it, then click on save and provide name to your report. Then click on save. This report has been saved to our workspace. So to see this report, let's close this and semantic model as well. Then click on your workspace. Here you can see a semantic model as well as our report. Now we will see how we can connect to a semantic model through Power BI Desktop. Now go to your Power BI Desktop. In Power BI Desktop, click on Data Hub, then click on Power BI Semantic Models. Then select your model and then click on Connect. You can see all the table has been imported successfully. Now let me show you the model view. Click on Model View. Here you can see our model. So right now our model is in a direct link mode. So in direct link mode, we can create only measures. We will not be able to create any calculated column. If we want to create calculate column as well as measure, then you need to convert your model to direct query mode. So to convert the model from direct lake to direct query mode, you need to click on transform data, then click on transform data, and it will ask you to change it to direct query. Click on add a local model. After this, select all your table and then click on submit. Now click on close and apply, and your model has been changed to direct query. So if you click on these three dots here, you can see lot of options are there. You can delete the table from your model, and even you can create the column as well. Now using your model, you can start creating your report, and then you can publish it into your workspace. That's it in this video. I hope you like the video. Please do like and subscribe, and in case of any suggestion and improvement, please provide your comment. Thank you for watching this video.